Hello learners, welcome back. I am Rajat Tiwari, lecturer, University Teaching Department, Chhattisgarh Swami Vivekanand Technical University, Bhilai, and your subject matter expert for this course. In today's session, we are exploring the topic of leveling, focusing on different methods and classification, adjustments and field procedure. We will delve into the various methods of leveling, understanding their classifications and learning the necessary adjustment and procedures required in the field to ensure accuracy in surveying projects. We will be discussing the following points in this session, including permanent adjustment, different methods of leveling, classification of leveling, balancing backside and foresight, and the field procedure in leveling. So, as we have already discussed temporary adjustment in the previous session, so we will move on to permanent adjustment. Permanent adjustment in surveying instrument like levels are essential to ensure the accurate positioning of the key component relative to each other. These adjustments should be precise as possible for reliable measurements. In practice, when using a level, if the distance for the backside and foresight are equalized, any errors from the imperfect adjustment can be minimized, while achieving perfect permanent adjustment is not strictly necessary if proper measurement techniques are followed. Surveyors should still be skilled in testing and correcting their instrument. The testing of level relies on the principle of reversal. This principle states that any existing error in a part of the instrument can be detected and doubled by reversing the part's position through 180 degrees. The fundamental lines in a level include the axis of bubble tube, the vertical axis, the axis of telescope, and the line of collimation. These lines have specific fixed relationship that are often disrupted due to the mishandling during field use, requiring regular adjustment. The desired relationship among these fundamental lines are that the vertical axis should be perpendicular to the axis of the plate bubble tube. The line of collimation should be perpendicular to the vertical axis. The axis of the telescope should align with the line of collimation. Now, we will be discussing about different methods of leveling. The following methods are used to determine the difference in elevations of various points. First one is direct leveling. Actually, this is the most common method of leveling. In this method, a spirit level is fixed to the telescope of a leveling instrument that is used to make the line of sight horizontal. Then, all the vertical distances are measured with respect to this line of sight. These vertical distances are used to determine the difference in elevation of various points. The direct leveling is also called as spirit leveling. Next, leveling we will be dealing is the trigonometric leveling. This is the method of leveling in which the difference of elevations is determined indirectly from the horizontal distance and the vertical angle. As the trigonometric relations are used to determine the elevations, this method is called as trigonometric leveling. This method is particularly useful in topographical surveys, such as determining the elevation of structures like buildings, chimneys and church spires, etc. It is also advantageous in challenging terrains such as mountainous areas. Next method of leveling is barometric leveling. It is based on the principle that elevation is inversely related to the air pressure. Though this relationship varies due to air's compressibility and weather conditions, this method is useful in rough terrains where high precision is not required, and for converting slope distances to horizontal. An altimeter, a modified barometer, is used to measure relative elevations. Next type of or method is hypsometric leveling. It is a method for determining the altitudes of various points using an instrument called as hypsometer. This instrument operates on the principle that a liquid boils when its vapor pressure equals the atmospheric pressure. Notably, the boiling point of water decreases as the atmospheric pressure drops, which occurs at higher altitudes. The method involves measuring the boiling point temperatures at different locations to determine the elevations. Next, we will be dealing with the classification of direct leveling. Basically, leveling can be broadly classified into two main categories. First is simple leveling and second is differential leveling. So, what is simple leveling? Actually, this type of leveling is used to find the difference in elevation between two points that are both visible from a single position of the level. Simple leveling is ideal when the elevation differences between the point is not too large. To minimize the effect of Earth's curvature and any potential instrument errors, it is recommended to position the level so that the distances to both points are equal, although they do not necessarily have to lie on the same straight line. Suppose A and C are two points whose difference in elevation is required with the level set up at B as shown in the figure. So, the procedure or the process of simple leveling involves the following steps, which include: firstly, we have to set up the instrument, we have to ensure the level is correctly positioned and leveled. Secondly, we have to target at point A. We will aim the telescope at the staff held vertically at point A and focus the lens to clearly see the graduation on the staff. Next, we will take a reading. We will record the reading where the central horizontal crosshair of the telescope's diaphragm intersect the staff, ensuring the bubble in the level is centered. Next, we will move the staff to point C and relocate the staff to the second point. Next, we will target point C. We will aim the telescope at point C and refocus the lens. Next step is to check the bubble. We will verify that the bubble is still centered. If it is not, we will adjust it using the foot screw closest to the telescope or with the micrometer screw if using a tilting level. We will take the second reading in the next step and record the reading of the central horizontal crosshair on the staff at point C. With this example or illustration, you can give or you can have more detail on this topic. Let us have an example. Let the respective readings on staff A and staff C be 2.855 meter and 0.525 meter respectively as shown in the figure. The difference level between A and C will be equal to 2.855 minus 0.525, that will be equal to 2.330 meter. Now, if in the question reduced level of A, that is station A, is given as 500 meters, then we have to find the reduced level of station C. So, we will calculate it as we know the reduced level of point A is 500 meters, then first we will calculate the reduced level of the line of sight, that will be equal to the reduced level of point A plus the back sight reading at station A, that will be equal to 500 meters plus 2.855 meter, that will be equal to 502.855 meter. Then we can calculate reduced level of the point C, which will be equal to the reduced level of line of sight minus the foresight at station C, that will be equal to 502.855 minus 0.5 to 5 meter, that will be equal to, your answer will be 502.330 meters. In the next illustration, if one of the point is on the floor and other on the ceiling, such as in tunnels or buildings, the staff at the elevated point may be held vertically inverted as shown in the figure. So, in the question, if the elevation of A is given as 200 meters and backside reading on A is given as 2.655 meters and the foresight on B is given as 2.835 meter, then the reduced level of the line of sight will be equal to 200 plus 2.655 meters, that will be equal to 202.655 meters. Then the reduced level of point B will be 202.655 meters plus the foresight at station B, that is 2.835 meter. Then answer will be 205.490 meter. Hence, reduced level of point B will be 205.490 meters. Next type of leveling is differential leveling. Differential leveling is used to determine the difference in elevation between two points that are either too far apart or obstructed by intervening terrain. In this method, the level is set up at multiple locations along the path between the 2 points, and the elevation differences between successive points are measured. This method is also referred to as fly leveling, compound leveling, or continuous leveling. Let us suppose that A and B are 2 points which are far apart, and the difference in the elevation is to be determined by differential leveling, as you can see in this figure. So, the procedure to find out the level difference is or include, first step is to, we have to initial set up the level. We will position the level at point O1, ensuring that the line of sight can intersect with the staff held vertically at point A. We will properly level the instrument. In the second step, we will take the backside reading. With the leveled bubble centered, we will take a reading from the staff at point A, known as the backside reading. In the next step, we will select an intermediate point. We will choose an intermediate point C that is roughly equidistant from the level's current position O1. We will take a foresight reading from the staff at point C. In the next step, we will move the instrument. We will shift the level to a new position O2 and level it correctly. In the next step, we will take the backside reading at point C. Again with the bubble centered, we will take a backside reading from the staff at point C. In the next step, we will choose the next intermediate point. We will select another intermediate D at a similar distance from the new position O2 and take a foresight reading from the staff at D. In the last step, we will repeat the process. We will continue this process, moving the level, taking backside and foresight readings at each successive point until you reach point B and take the final foresight reading there. Now, let us take an illustration. For example, x1, x2, x3, x4 and so on be the backsides, and y1, y2, y3 so on be the foresights taken on the staff held vertically at A, C, D, etc. Here, difference of level between A and C will be equal to x1 minus x2, x1 minus y1. Difference of level between C and D will be x2 minus y2, and difference of level between N and E will be x3 minus y3 and so on. The difference of level point A and B is equal to the difference of the algebraic sum of the backsides and algebraic sum of the foresights, that is sigma backside minus sigma foresight. So, if the difference in level is positive, then the closing point B is higher than the starting point A, whereas if negative, the point B is lower than the point A. Reduced level of point B will be equal to reduced level of point A plus or minus the sigma backside minus sigma foreside. Next leveling type is check leveling. It is the operation of running levels to check the accuracy of the benchmark previously fixed. At the end of each day's work, a line of level is run returning to the benchmark with a view to check the work done on that day. Next type of leveling is fly leveling. It is a leveling method used to quickly determine approximate elevations along a specific route. It is typically employed during the initial reconnaissance phase for linear structures like roads, railways, tunnels and canals, etc. Next type of leveling is precise leveling. It uses highly accurate instruments to achieve greater precision compared to ordinary leveling. While the basic method is the same, precise leveling involves longer level loops and stricter error control, particularly by balancing foreside and backside distances within 0.5 meters. This minimizes error due to collimation, curvature and refraction. Steadier wires on the instrument help in maintaining equal side distances. Next type of leveling is reciprocal leveling. It is a technique used to accurately determine the difference in elevation between 2 points by taking 2 sets of reciprocal observations. This method is particularly useful when it is impossible to set up the instrument between the points due to obstruction like valleys or rivers, or when the side distances are longer than usual. In such cases, error from staff reading, earth curvature and instrument imperfections become significant, and reciprocal leveling helps to minimize these errors. Next type of leveling is cross section leveling. Cross sectioning is a leveling process used to determine the elevation of points perpendicular to the center line of a proposed route and radially on curves. This method provides vertical profiles of the earth's surface. The detailed level data on either side of route's longitudinal section is crucial for calculating the volume of earthwork required. Cross sections are plotted similarly to longitudinal section with both horizontal and vertical measurements using the same scale. Next type is longitudinal or profile leveling. It involves determining the elevation of point spaced along a specific line to accurately map the ground's surface profile, also known as sectioning. It is essential for projects like constructing sewers, pipelines, highways, railways, canals, etc., as well as for calculating cut and fill. The process relies on differential leveling, which requiring multiple change points and intermediate sites at key locations such as slope changes or breaks in the ground. These readings along with chainage are recorded in the level book. The method provides crucial data for comparing different route options and include noting features like stream beds, roads and culverts along the section line. Next topic we will be dealing with how to balance backside and foreside distances. Actually, in leveling, it is very crucial that the line of collimation remains horizontal when taking staff readings. The line is perfectly horizontal when the bubble in the level is centered, but achieving this with absolute precision is difficult. Typically, when the bubble appears centered, the line of collimation may still form a slight angle with the horizontal. Since the error from the misalignment increases with the length of the site, it can be minimized by keeping the backside and foreside distances nearly equal. Let A and B be the 2 points, each being at a distance d from the level as shown in the figure. Let the line of collimation be inclined at an angle with the true line of collimation, that is A O dash B. Observed reading on staff A is capital A A1, whereas true reading is capital A small a. the observed reading on staff B is BB1, whereas true reading is BB. Then the error introduced are A1 and B1. So, the true reading at A is AA, which will be equal to AA1 minus small a1, that will be equal to capital A1 minus D tan alpha. True reading at B is BB, that will be equal to BB1 minus small bb1, which will be equal to capital BB1 minus D tan alpha. So, the true difference of level between B and A is BB minus AA. Solving the equation, we will get BB1 minus D tan alpha minus AA1 minus D tan alpha, which will result in BB1 minus AA1. So, from the foregoing, it is evident that the error is completely eliminated by equalizing the back side and fore side at equal distances. Next, we will see the field procedure in leveling. The field work in leveling involve basically three main tasks consisting of reconnaissance, second is to taking observations, and thirdly recording them in the field book. The first step includes reconnaissance. Before starting the leveling process, a preliminary survey or reconnaissance is conducted. This involves locating fundamental benchmark that will guide the level lines. The route for the leveling is carefully examined to decide the positions of temporary benchmarks. After this, the locations for the staff stations are determined. Next step is of observation or how to take the observation. Before beginning the leveling work, the surveyor must check that the instrument is properly adjusted and in good conditions. Observations are made on the leveling staff using the horizontal crosshair of the instrument. If the instrument has stadia wires, reading for these may also be taken. The average of the stadia hair readings should match the readings from the crosshairs as a verification check. So, in noisy or busy areas where verbal communication is very difficult, then hand signals are used to guide the staff holder. The signals include, so this is the table in which we have been given the signals and the message. We will see one by one. So, first signal is movement of left arm over 90 degree, which will give the message move to my left, as you can see in this figure. Next is movement of right arm over 90 degree, the message will be move to my right. Next signal will be movement of left arm over 30 degree, the message it will give move top of staff to my left. Extension of arm horizontally and moving hand upward, the message it will give is raise height of peg or staff. Extension of arm horizontally and moving hand downwards, the message will be lower height of peg or staff. If the extension of both arms slightly and thrusting downward, then message will be establish the position. And in the last, if the extension of arm, placement of hand on top of head, then message will be return to me. So, these signals, as you can see each of this signal in this diagram one by one. Next will be third step will be booking and reducing the level. The observations are recorded in a level book. There are two methods of booking and reducing the levels of the points from the observed staff readings and are described as follows. First method is rise and fall method and second method is height of collimation method. So, we will discuss about rise and fall method. In this method, the difference of level between two consecutive points for each setting of the instrument is obtained by comparing their staff readings. The difference between the staff reading indicates a rise if the back staff reading is more than the foresight and a fall if it is less than the foresight. The rise and fall worked out for all the points given the vertical distance of each point relative to the preceding one. If the RL of the back staff point is known, then the RL of the following point may be obtained by adding its rise or subtracting its fall from the reduced level of preceding point, as the case may be. The specimen page of a level book illustrating the method of booking staff readings and calculating RLs, that is reduced levels of station, by the rise and fall method is as shown. This is rise and fall method of reduction of levels. Next, what are the arithmetic checks used in rise and fall method? The difference between sum of the backside and the sum of the foresight should be equal to the difference of sum of rises and the sum of falls, and should also be equal to the difference between the rise of the last point and that of the first point. In this method of reduction, a complete check on the intermediate sides also is provided, because these are included for calculating the rises and falls. Next method is height of collimation method. In this method, height of instrument HI is calculated for each setting of the instrument by adding backside to the elevation of the benchmark. The reduced level of the first station is obtained by subtracting its foresight from the instrument height. For the second setting of the instrument, the height of the instrument is calculated by adding the backside taken on the first station to its reduced level. The reduced level of the last point is obtained by subtracting the foresight of the last point from the height of the instrument at the last setting. If an intermediate site is observed to an intermediate station, its reduced level is obtained by subtracting its foresight from the height of the instrument for its setting. The specimen page of a level field book illustrating the method of booking and the staff readings and calculating reduced levels of the stations by the height of collimation method is as shown. So, in this figure you can see the page of a level field book, which is showing the method of booking of staff readings and how the calculation of RLs are done. We will be dealing detailed numericals of height of instrument method and rise and fall method in our next lecture. So, the arithmetic checks of height of instrument method includes the difference between sum of backsides and sum of foresight should equate to the difference between RL of last station and the RL of first station. In this method, there is no check on intermediate sites are there. Now, we will have a comparison of line of collimation method with rise and fall method. So, in height of collimation method, it is more rapid and saves a considerable time and labor, while in rise and fall method it is very laborious, as the staff readings on each station is compared to get a rise or fall. For height of instrument method, it is very well adopted for reduction of levels for construction work such as longitudinal or cross sectional leveling operations, while rise and fall method is well adopted for determining the difference of levels of 2 points where precision is required. In height and fall method, there is no check on reduction of reduced levels of intermediate station, while in rise and fall method there is complete check on the reduction of reduced levels of intermediate station. In height of instrument method, there are only two arithmetic checks, that is the difference between the sum of foresight must be equal to the difference in RL of last session and first session, while in rise and fall method there are 3 arithmetic checks, that is the difference between the sum of the back side and the sum of the foresight must be equal to difference between the sum of the rises and the sum of falls, as well as it must also be equal to the difference in RLs of the last session and first session. Height of instrument errors, if any, in intermediate sides are not detected, but in rise and fall methods error in intermediate sides are noticed, as these are used for finding out rises and falls. Dear learners, we have reached the end of today's session. I hope you found it informative and engaging. Thank you for your attention. See you in the next session. Thank you.